Hey, welcome back to your favorite technical mathematics class. We're going to look at their geometric figures today. First, let's talk about the diagonal of a polygon. So that's just a line segment that joins two non-adjacent vertices. So let's go from this vertice D first. So there's 1, 2, there's 3 diagonals. From E we got 4, 5, 6 diagonals. From F we got 7, 8 diagonals, and from A we got one more 9 that we haven't repeated. So there's 9 diagonals in that one that are non-adjacent from the vertices. The sum of the interior angles of a triangle will always add up to 180. Like if this is 30, that's 70 degrees. The last one would have to be, since those add up to 100, the last one would have to be 80 degrees. They all add up to 180 degrees. The interior angles of a polygon will add up to 360. So if this is like 100, that's 100, there's 200, so that would be left with 80 and 80 on those. Those add up to 360. Chord. A chord is a line segment having its endpoint on a circle. So you can see it's got to go from endpoint to endpoint here on a circle. So the diameter is an example of a chord. See, this diameter goes and it stops. Whereas a secant line is going to go right through. Secant line is going to go through it. And a tangent line just touches once at one point. Oh my gosh, it won't. Just touches one right there. That's a tangent line. Okay. Central angle is where it's this angle right here at O. It's vertex at the center of the circle. An arc is the portion that is created from that central angle. So here's the arc AB right here, okay, or AOB, arc AOB, okay. So angle DOC is the central angle, so DOC, so you see the central angle right there, DOC. And if DOC is 50 degrees, so if this is 50 degrees, then the arc AB is 50 degrees as well. Okay, which means since the whole way around is 360 degrees, if that's 50, then AEB, arc AEB, so the rest of it would be 310 to make up the 360. Okay, which means that central angle in there would be 310 as well. All right, now an inscribed measure is where the vertex is on the opposite side. So you see the inscribed angle. What happens with an inscribed angle is it's going to be half of the measure of its intercepted arc. So in other words, if angle ABC right here is 30, so if this is 30 degrees, that means this is 60 degrees, which also means that the central angle would be 60. Okay. Over here, if you've got PSQ, so if this is 180 degrees, which means that's 180 degrees, but the inscribed angle, so it goes, the vertex is on the circle and it creates that arc there, then that's only going to be 90 right there. It's going to be half of it. Okay. So here's another one. Let's say, I don't know, let's say this is 70 degrees. Okay, then this, as well as its central angle right here, okay, both of those would be 140 degrees. Okay, so that's an inscribed angle. Well, let's use some of our characteristic, or of our knowledge of geometry here to solve this. If this is 90 degrees right here, that means this will be 90 degrees right here. And now you've got in here, you got 90 degrees right there. You got 40 degrees right here. So 90 degrees plus 40 degrees. And we're going to solve for this right there. Plus, I'll call that, I don't know, double angle. How about A? Those add up to 180. So here's 130 degrees plus this angle A I call is 180. So A's got to be 50 degrees. So right here is 50 degrees, which means by vertical angles, that's 50 degrees right there. Okay, and now you've got 50 degrees, you've got 67 degrees, so 50 degrees plus 67 degrees right there, and we're going to find this remaining one right here, call it Y. So 50 degrees plus 67 degrees, that's a 67 plus Y, all adds up to 180 degrees. So that's 117, so subtract 117 degrees from both sides, 117. So your angle Y ends up being 63 degrees. So that's 63 degrees, and then these two add up to 180, and you want X, remember. So X plus the 63 degrees adds up to 180, so subtract 63 from both sides. Angle X ends up being 117 degrees. Okay. Well, thanks for listening. We'll see you guys soon.